talk about is aircraft familiarization, and it's kind of basic. So our objectives are to state the basic functions. You can read all of this stuff. So we'll talk briefly about the functions of different aircraft control systems, and we'll talk about relationships of the magnetic compass and the heading indicator. That's important as scanners and pilots, that we know where the heck we're going so we can navigate and don't run into things and get to where our mission target is. We also need to understand the function of the instrumentation in the cockpit, that if you're a scanner and you're in the back seats, you'll kind of be observing from afar, but if you're in the front seat as an observer or a scanner, you'll be confronted by these things, and they can be somewhat confusing as to what they are. So we'll do a brief explanation of that. And we'll discuss the consequences of exceeding the gross weight limits of the aircraft. And that's going to be a little bit out of sequence, but we'll move that to the end. These are the tasks that you're going to be expected to be able to complete for your exam, for your written exams. And so you need to understand these and be able to see how they fit into the entire picture of what we're doing as scanners. Part of that, being part of the air crew, you're going to need to discuss ground operations and safety, which is important to everybody, air crew and ground crew. So those are important things. As Lieutenant Colonel Denisick said, we try to do a standardized approach to everything so that everybody's safe all the time. Taxiing is very important. Marshaling is very important. And understanding where you are and what's going on in the airport environment. So we're going to talk about those too. And then finally, we're going to talk about wake turbulence, including where it's most likely to be encountered. So that's going to be what we're looking at. So we'll start with talking about the major parts of the aircraft. And the reason you need to know this stuff is right up there on the screen. Structure, because you need to know your way around the airplane. You need to be able to understand the instrumentation and how they fit into the whole picture. Before we fly, we need to do a couple things. One of them is to inspect the aircraft for airworthiness and to make sure there aren't any parts and pieces hanging off, doing things they're not supposed to be doing. And also for safety, we need to do that, because it's better to be on the ground wishing you could fix a part than to be in the air going, God, I wish I had fixed the part. So you want to catch problems before they occur. All of this wraps up into safety and ground operations, safety issues also. And then wake turbulence we'll talk about later. And during the movement of the aircraft, whether it's initially leaving the hangar and getting out onto the flight line and the taxiways, or whether you're reversing the process and coming back, those are ground operations. And because we've got headphones on and people who are going to be guiding us, the marshalers, are going to be using signals, so hand signals, because they can't talk to us. So we need to be aware of and understand those. And as a scanner, these are important because as part of the air crew, you are going to assist the pilot in being able to observe those and know how they fit into things. So we're working with a sterile cockpit. In other words, we're not talking most of the time. So we need to be able to understand what's going on and convey messages to the pilot who's responsible for moving the aircraft safely. Overall, it's going to help you to be safe on the ground and in the air and promote effective communication from all crew members. Okay, so typically the airplanes that we use CAP fleet are the ones that are depicted here. The one that's at the top right segment, we don't have any in the Hawaii wing. That aircraft is the Gippsland Air Van, and we don't have any as far as I know in Hawaii. Is that correct?
That is correct. We do not have any.
Okay. I believe they're used for, was it Archer? The Archer system and several other things we don't have access to, and that, so I'm not going to spend any time talking about that particular aircraft. But the other three are very common to what we have. And those would be the Cessna 172, which we have a number of them with and without G1000 flight data information. I don't think we have any 206. I don't think we have any 206s here in Hawaii. Is that right, Wayne?
That's correct. We're trying to get one for the Big Island because of the high altitude of the mountains there.
So if you look at the left-hand side of the screen, 7.3 Echo on top and 6.1 X-ray below are more typical of what you're going to see here in Hawaii. However, I'm bringing up the others because the point of this training is supposed to be universal. So if you wound up in Colorado wing because you were on vacation, or like one of the gentlemen who's from Florida, I think it was, who's gotten stuck here in Hawaii, what a horrible fate. But if we had a mission and you're mission qualified, you would probably be a useful asset with your experience here in Hawaii. So you've got maybe familiarity with different aircraft than we have, but the overall training is supposed to be unified. So we're going to talk about those, all of those items. The airplane parts are here in the illustration, and the basic components are control surfaces. So this is a little bit of detail about how these things work. So on the aircraft, in the left-hand indication, you see the ailerons. The one on the right is down, the one on the left is up. And basically what it does is the one on the left, if you were to imagine that we had two people standing on those two wingtips, and the one on the right side was standing under the wingtip and pushed up, and the other one pushed down, which way would the aircraft want to lean? So it would want to rock to the left, because the right wing is going to go up because of more lift, and the left wing is going to go down because of missed lift. And so it's going to move the wings to the left. And that's illustrated in the top picture and the bottom picture. So without going any further in that, that's how ailerons work. They control roll. If we have the center of gravity of the airplane, we're talking about the elevator here. You can see it in the illustration. If the elevator surfaces are pointed up, then the aircraft nose will want to go up. If it's pointed down, the airplane nose will want to go down. So just moving through that. The rudders are used to move the nose of the aircraft left and right. That's called the yaw. And that, in conjunction with the ailerons, is how we turn the airplane. So the yoke does not steer the airplane, but the ailerons and the rudder do. And that's important. So when you get in the airplane, you'll see that the pilots or observers have their feet on the rudder pedals, and that's how they control that movement of the aircraft. Okay, so in the back, you've got a trim tab, and basically what the trim tab does is, because the airplane's moving through the air, it's getting their forces working on the control surfaces, and those forces have pressure, and we overcome those pressures with muscle energy, our muscles. If you get tired of pushing on that all the time, or pulling, or twisting, you can take that pressure off, and once you put the airplane the way you want it to be, it will stay stable in that position. So we use the trim tabs to do that. Commonly, there's a trim tab on the elevator surface, but in some of the aircraft, like the 182s, we have elevator trim as well as rudder trim, because that airplane has a lot more torque, and so you need more pressure to move the nose around. The fuel selector, very, very important. The fuel in our airplanes are stored in two different tanks. They usually flow together when the dial is in the center, like indicated here. But if you turn the pointy end up at the top to the right or the left, you're feeding fuel only off of that particular tank. Most commonly on takeoff and landing, you have it on both. So it's important to check all the time or periodically, suggested 30 minutes, to make sure that that didn't get inadvertently knocked out of the correct position and be pointing on the right tank, for instance, or the left tank, and you expire all the fuel out of that tank, haven't looked, and all of a sudden you hear the engine, instead of going, it goes, and then somebody goes, uh-oh, we got a problem. So you want to check and make sure that that doesn't get displaced inadvertently during the course of the flight. So it's suggested as here, every time we report an ops normal, which should be about every 30 minutes. And whose responsibility is it to check? It's the pilot, it's the observer, and it's the scanners. The scanners can see it often very well because they're in the back seat and they can see if it gets dislodged. So it's a crew responsibility, and so we should have that as a normal thing of our checklist to or procedures to make sure that every time you call in ops normal, before you do, look down at the fuel selector valve and ensure that it is in the normal position, what you want it to do. Now, sometimes because when we fuel the aircraft, we don't get exactly the same amount of fuel in both wing tanks because of a lot of different reasons, but sometimes that occurs and you'll have more fuel in one wing than the other. The wing that has the most amount of fuel, the airplane's going to want to lean in the direction of that particular tank. So you have to correct for it with trim. It's mostly rudder and aileron to control that. And if you don't want to be holding that position all the time, you can trim it out if you have an aircraft with rudder trim. So every 30 minutes, just make sure that that's part of the process. Okay, so we're going to look at some major instances. When you look at a cockpit, you got all stuff in, and it looks like, geez, it's all complicated and all that. And it's really, really not. This is what's commonly known as a glass cockpit. And if you were to look at these, on the left-hand side, the TV screen there with the round dial at the bottom, that's called a flight management display, or
primary flight display.
Yeah, primary flight display. Thank you, Daryl. And then the multifunction display is on the right-hand side. They do a lot of things, but they consolidate into two essentially television screens. All of the instrumentation that is in what used to come from what we call steam gauges or round gauges, which we're going to look at in a minute. If you look all the way to the right, you'll see, or the middle and the right, you'll see a green circle. Those are the communications panels for navigation and communication that are accessible to both the pilot and the co-pilot or observer. So that's what the dual audio panels are. Go continue to the right of the right-hand green circle, down on the bottom, just over the yoke, you'll see the Becker direction finder and the FM radio. Those are used for conducting searches and also for communicating on the CAP FM frequencies that we commonly use. If all of that stuff goes out the window and just rolls over and does a dead bug on you, then we've got a backup, and those are the backup instruments, obviously, that show the important stuff of, from the left, the airspeed indicator. It's important to know how fast you're going through the air. Also, how the artificial horizon, which tells you how the airplane is related to the ground. So if you're flying, you can't see outside the cockpit, you use a device like that to replicate the horizon so you can tell whether the airplane is turning right or left if it's level, if it's climbing, if it's descending. And then finally, your altimeter. It's important to know how far you're above the ground, because if you're 800 feet above the ground and there's something above in front of you or around you that's 1,000 feet above the ground, you're going to own a piece of the rock. So it's important to know how far you are up in the air. Okay, this is an example of steam gauges. This is what we have typically had in our aircraft here in Hawaii. And I think most of the fleet on the mainland is being converted from the steam gauges or round gauges to what you just looked at with the electronic gauges or the glass cockpit. In the middle, yeah, everything's labeled, but your primary flight instruments, your aircraft navigation radio panels, and your CAP and communications and navigation panels are on the extreme right side. And that's very typical of the aircraft. For those of you who are here on Maui and several other places too, I don't know what airplane the Wheeler has. Wayne, do you know?
We've got 3 glass cockpits. We got one at Hilo, one at Honolulu, and one in Kauai.
So the majority of planes you're going to see here in Hawaii, I think we've got 9. The majority of them are going to be steam gauges as illustrated here. Okay, this is a big version of what you're looking at on the glass cockpit. And if you look on the left side that's circled in red, you'll see that that is the airspeed indicator for the aircraft. So it's looking like it's indicating 120 knots for airspeed. Then on the right and on the bottom in the middle, where it says GPS and ENR, that's your directional gyro. So it lines up with the compass, which we talked about earlier, or about to talk about. The compass and that, you should match the two of them so you know what heading or direction you're going in, a magnetic heading or direction. And then on the right-hand side is your altitude, your altimeter. So this is the way it's depicted on a glass cockpit. Down below, there are other information for navigation and so forth. Up top, your radio frequencies for navigation on the left. And then for your communications radio 1 and 2. And those things are down there. And those are the key things that you need to be aware of. This is another version. This is the same display, but this is indicating terrain, and it's giving you visual information about the terrain that's around you so you have better situational awareness. In other words, if everything like on the left-hand side is red, it's indicating terrain that's basically, if it's in red, it's the danger zone. You're too low relative to that terrain. So that's where your altimeter needs to come in. You need to get up higher so you can clear that. That's essentially what that's saying. Okay, next thing is our compass. This is the old reliable thing. Some people call it a whiskey compass or a wet compass. As it says, no power required. They work very well. There are some limitations to compasses, and the pilots are going to deal with that. But basically, you want to know which direction you're going in. And it's important because runways are numbered based on the magnetic heading of the runway. So if you're going to land on runway 36, that means the end, you're going to be facing north or 360 degrees. If you were told to take off from runway 270 and your magnetic heading when you're about to sit on the runway is something other than 270, you have a problem. So you need to set the digital or the directional gyro, and the compass should match what the runway heading is. So all airplanes have to have a compass. I don't care how simple the airplane is. Different things that you do with the bank angles and speed changes of an airplane can put errors into the compass, which can be dealt with, but you have to be aware of it and not just blindly fly the compass. Your pilot's job is to take care of that, but you should be aware of it as a scanner. And that's about all you need to go for that. Okay, this is another version. You see two versions here, a vacuum powered on the left and a digital powered on the right of the same thing. This is a directional gyro. It's set to match the heading of the compass and or the runway that you're sitting on. And you want to make sure that those match all the time so you don't have problems. With directional gyros, the benefit is that they're stable. Compasses can move around. If you're turning or accelerating or decelerating, you can have errors built into compass that give you a wrong reading, a false reading. So with this, they work off of gyros, either driven through vacuum or electronically on the right-hand side. Those are driven by those forces, and those are very, very stable as you move through space in the airplane. They also tell you very quickly that you're turning. So if you're like in the illustration on the left, you're on a heading of just a little bit more than 10 degrees clockwise from north, then if you start a turn, you're going to see that if you start turning to the left, that number is going to change. So that tells you very, very soon that you're making a turn. That pretty much covers that for the practical end of it. Altimeters, they work off of a system on the airplane called the static system. And basically what happens is air gets rammed into a tube, and the tube knows what the pressure is and the pressure outside, the atmospheric pressure, and you can set it with the little window on the right-hand side, and that will tell you how far you are above the ground. It's called pressure altitude. Having said that, if you were at an airport that was at 500 feet, that big needle, big meaning the long one, that would be at the number 5. Right now it's like 840 feet. The window on the side where you see the 29.992, that's called standard atmospheric pressure. So when you go up in the air pressure around you gets less. And so, well, that's how the instrument tells that you are higher than sea level, because the atmosphere is always going to be 29.92 at sea level under standard conditions. So if you have a number that's bigger than that, like 30.0,
basically it compensates for non-standard pressure. So all altimeter is a pressure gauge, but instead of being calibrated in PSI like a tire pressure gauge, it's calibrated in feet. And it assumes a standard atmosphere. But if the atmosphere isn't standard, if it's higher pressure than normal, a high pressure area, then that air is going to be denser than normal. And so that altimeter would read lower than actual altitude. And I guess the only other thing I'd say is remember that the pressure altimeter, which is the one we're talking about here, gives you your altitude above mean sea level, not above the ground. It tells you how high you are above the sea. So if you're flying over terrain that's 300 feet terrain, let's say, then your actual elevation above the terrain is 540 feet in this example.
So basically, it's important to know this so that you don't run into stuff. That's the easiest way. On the right-hand side, you'll see a display of altitude in a digital format. Okay, it's turn coordinator. It's generally run by electric. I think all the aircraft in our fleet here in Hawaii are the ones that are illustrated. I don't think anybody has a needle and ball in the traditional sense. Do you know of any here, Wayne, or any CAP aircraft that have the old style?
No, I don't think so. They call this style the wing leveler, because you can kind of use it to level your wings if you lose your attitude indicator. Yeah, all of our airplanes would have this style.
Okay. So basically what this tells you is the rate that you're making turns at. So In 2 minutes, you would do a complete circle if you have the wingtip of the little airplane that's depicted there on the L or the R mark, then you're going around at 2 degrees a second. So you would make a complete circle in 2 minutes. The ball on the bottom is an inclinometer, and it basically tells you whether you're in coordinated flight. If you're not coordinated, the ball will be to the right or the left, which means you need to step on the rudder pedal in the direction that that ball is pointed. So the common thing is to step on the ball. Over here is the vacuum gyro, the artificial horizon. We talked about that before. But basically, you can see the blue part is the sky, the brown part is the ground. Don't want the airplane pointed down at the ground unless you intend it to be. But you don't want it pointing too high up into the blue. So this is when you can't see the ground, this gives you additional information. It's also useful even when you can see the ground. It tells you what position the airplane is in, vertically and laterally and horizontally. Airspeed, got to have airspeed to fly. The green stripe is the area where you're in a normal operating range, and that goes from about 63, 62, 63 up to 140 knots. The white arc is the flap operating range, and that's important if you're using flaps while you're flying. And then the yellow part is the caution range for speed, and you don't want to be in that area unless you're in very smooth air, no bumps, no turbulence, that kind of thing. Pilots use this so they can tell how fast they're going through the air. The strip on the right-hand side tells you the same kind of information with color coding, and at the bottom it tells you your true airspeed is 170 knots in that case. And vertical speed tells you how fast up or down. So if you pull back on the yoke or the stick, the nose goes up and the speed goes down. If you push the other way, the nose goes down, the speed goes up. And the faster you are going down or up, this is tell you you're going up at 500 feet a minute or 100 or 1,000 or down and so forth. So that's used to tell whether you're flying level or not. If that's on 0, then you're not moving. In this case, it looks like it's about 50 feet a minute. Okay, a glass cockpit again. A lot of the instrumentation that you have that we looked at in the steam gauges, the 6-pack, the old round gauges, that's displayed here on the left side, where it tells how much power your engine's putting out, how fast it's turning around, how many RPMs of the propeller, or in a fixed propeller airplane. And it tells you all the important parameters of the airplane, the engine, its performance, the fuel burn. And then up top, it's telling you in the magenta where it says GS, that's how fast you're going over the ground. Where it says TRK, it's telling you what your track over the ground is, and so forth. Those are things that the pilot will deal with, but this is source of information for them.
If you'll take your attention over to the upper right corner where there's a yellow square, and it starts, there's some numbers there, N47 and then W122. Those numbers are your latitude and longitude. And one of the things that's important in scanning is if you locate something, you want to be able to go back and find it again. And so it's really important to do what we call marking your position. And that means noting what the coordinates are so you can go back to that same area. And if you look along the right-hand side of that bezel, if you start at the bottom, there's a knob labeled FMS, and then there's 6 push buttons, and then there's one labeled range. Well, that range button is actually a little joystick. And to activate that joystick, you push it in. When you push that in, what it does is activates a cursor. And if you look in the very middle of the display, you see a little white airplane, and there's a black cursor on that airplane. I'll give you a minute to locate that. So basically, when you first press that button, that black cursor is going to overlay your airplane, which is what your current position is. And the coordinates of wherever that black cursor is are displayed in that square on the upper right-hand side. So if you're flying along and all of a sudden the pilot asks you to mark your position, all you have to do in a G1000 airplane is press in on that range button, push it in. The black cursor will appear right over where the airplane is, and then you'll have those coordinates and you can write them down. The format for the coordinates, we'll talk about that later. Either I will or Daryl, I'm not sure, but it's in degrees. So it's north 47 degrees, 32 is the minutes, and then decimal 90 is tenths and hundredths of a minute. So that's north 47 degrees, 32 minutes, and 9/10 of a minute. And then that's latitude, and then the longitude is the other number there. And that's the standard format we use in CAP. There's different ways you can express latitude and longitude, but we always express it as degrees, minutes, and then decimal minutes, as opposed to degrees, minutes, and seconds, which is another convention, but we don't use that convention. So the salient point on this is to mark your position in a G1000 airplane. All you have to do is reach over and press that button, and the cursor will show up on top of the airplane, and you'll have the coordinates right there. You can't do any harm. You're not going to screw up the pilot, whatever he's doing. It's not going to affect anything. So don't be hesitant to do that if the pilot asks you to mark the position. Back to you, Chaz.
Thank you. Tachometer tells how fast the crankshaft is of the aircraft, of the engine is turning. The green arc is the normal operating range. The red line over about the 2 o'clock position is the maximum speed for continuous power or RPM. So you want to always stay at or below that. Typical cruise would be something about what's shown there, about 2,400 RPM, 2,200 RPM. That's what the pilot uses. On the G1000, as you can see, this is a constant speed propeller, and it's showing on top manifold pressure, which is how much power the engine is putting out, and RPM is how fast the propeller is turning. On a constant speed propeller, it will stay the same speed all the time. And so if you set it at 22, it'll stay at 22, but without getting all complicated about it, unless you're in a constant speed propeller airplane, then basically most of the time you're going to, well, if you're not in a constant speed airplane, you're only going to be dealing with the RPM, because that's the measure of power and everything else all in one. The G1000 displays is here, and it's good because it tells you your oil pressure and temperature and all that kind of stuff, your engine hours, and that's really nice information to have. Other instruments, gas gauges in airplanes, particularly our older fleet, the majority of them, except for those glass cockpits that Colonel Denisick was talking about, are going to have those old analog gauges, and they're notoriously imprecise. Quick story, I remember I was flying with Colonel Denisick, and we were in Honolulu, if you recall, and we thought we had enough gas to get back home, but he looked at the gauge and said, I don't trust them. So we filled up the airplane, so we knew that we had enough gas because we could put our eyeballs on it. And that's not a bad habit to do. And that comes into play with, we'll get to that when we get to talking about pre-flighting the airplane a little bit longer or a little bit later. But unlike your car, if you're in an airplane and you read that gauge that says empty at the bottom when it's 10 gallons, and you get to the understanding, when that reads that, I got 10 gallons left, that's another 100 miles. In airplanes, it doesn't necessarily work like that. So being prudent with looking at your put your eyeballs on the fuel supply is extremely important in the aircraft that we're exposed to. So don't take it for granted. Even we use a stick. It's basically like a pipette that tells you exactly how much fuel you have in each tank. And when we're filling the aircraft up or refueling it, we always use that. And I call it Denisic's rule. So we always have the stick when we're doing that. So it's important to learn that I learned from him. Okay, audio panels. This is what you use to route communication, verbal communication back and forth to the places we need it to go. This is indicating a glass cockpit array. They look a little bit different than the ones that we use, and we'll get to those in a minute in the next slide. Mission observers should always ask, and if you happen to be a scanner that's in the observer seat up front, then you always want to ask and check with the pilot before you make any changes, because that's just good procedure. You don't ever want your pilot to be transmitting or thinking they're transmitting and they're not. When they need to talk, they need to talk. So make sure you don't futz around with things and get everything discombobulated. And once you got permission to go ahead and make the change, tell them that you're back on where it was and there are no changes. It's very important to communicate that way with your pilot if you want to get along with them. Mission scanner has the ability to listen and communicate in the back seat. Now, I don't know if that's true in our airplanes in the back. Colonel Denisic, you got a comment on that?
Yeah, we do have mic and headphone jacks in the back, and you can listen to whatever's selected on the comm panel for the right seater.
Well, I understand that, but you can listen, but can you send a message out, or is it just intercom?
Now, that varies from plane to plane. Some of them have a push-to-talk spring-loaded toggle switch, and some don't. And I don't recall on 47 Echo, our Maui Bird, which one we have.
Okay. Well, that should be something that as a scanner, when you're in an airplane that you don't know, it would be a good idea to ask that question. If I'm going to be in the back seat, how do I communicate with the pilot, the observer, or the ground resources? So that's important to find out. How do you communicate? Okay, this is a more traditional audio panel. And a lot of our airplanes still have these, or have they all converted?
The one on the bottom is still used for the non-G1000 airplanes.
So you'll see that there's COM 1, COM 2, COM 3, and then there's COM 1 over 2, COM 1 over 3, and COM 2 and 3. And you can swap those back and forth, and I'm not going to get into a big deal on it. Your pilot will tell you what the rig is for the particular aircraft you're in and how to operate that if necessary. Most of the time, the pilot is going to be the one who's doing that, but if there's an observer there, that's part of their tasking too. These are the old version of the Comm Radios. At the bottom is the glass version for navigation. You can see down on the left in the glass version. And you can flip-flop those. So the 109.10 on top can be switched to nav 2, which is the 117.95, and you can invert those. Or I'm sorry, not invert them. You can have a standby radio. So you have 109.10 is active, 109.90 is the next frequency, so you can switch those two without having to switch radios. You're just changing the frequency. So you can have multiple channels up. The comms are the same on the other side. On the top depiction, and I don't think any of our airplanes have that anymore. Colonel, you got input on that? I think we've all converted to all the 9 glass ones have converted to the new format with the Garmin systems, right?
Correct.
Okay. So I'm not going to spend any time talking about the ones on top. Essentially what happens is you can do the same thing, except you're turning knobs and dials to do it instead of hitting soft keys and so forth. You'll get more familiarity about that when you're actually hands-on in the radio during your training, but we're just going to familiarize you with it here. Okay, this is where the multiple function display has all the kinds of things we were talking about, and Colonel Denisick spoke about a lot of those things. Basically, what you have is a map that indicates where your airplane is, which is in the middle on the left side of that river fork. Looks like a heart, looks like a right ventricle, but there's the airplane down there. There are other airplanes around and they're tagged. And this is because of a thing called ADSB. Basically, it's a way of identifying airplanes that are in your area, and it helps you visualize traffic that may be a factor to you. It may not be a factor to you, but it makes you more aware of what's in the airspace around you. And it also helps air traffic control know where you are and what you're doing. On the left side is your instrumentation for your engine and your power and so forth. Up top is your navigation stuff. On the other side are some of the other accessories the Colonel was talking about. I don't think we have any of these, the Apollo GX55s in our fleet anymore. Is that correct, Colonel?
That's correct, thank God.
Okay. It's an old school GPS, like my email address is old school. I couldn't learn the darn thing, and I'm so glad that they switched out of it. So I'm not going to spend a lot of time of it. It's not there anymore. So, do you know if the entire fleet has converted or the majority of it?
I don't know. I assume that everybody's gone now because ADS-B basically drove part of that Garmin upgrade. So in order to get the ADS-B, you had to go with the Garmin, or you don't have to, but that's what the CFP elected.
Oh, okay. Okay, the transponder, inappropriate by some pilots, called the fish finder. What it does is it sends a signal out so that air traffic control can tell who you are, where you are, how high you are in altitude. So it helps them figure out all of that stuff so that they can move traffic around efficiently and prevent collisions, incursions, all that kind of thing. And basically, it's a 4-digit code. At one time, it was 3. And what it does is when the radar sends out a pulse, it looks for a return. And that return that you have, the address of that return might be 1946. That's what air traffic control assigns you as a number for your transponder. It's called squawking your transponder code. And when they ask you to squawk your transponder, that means you push a button, and when the radar hits your airplane, it's going to pick up whatever number was in there and identify that on the radar screen. If you look down here, and you'll see on the right-hand side, there's a yellow dot with a line on it and the number +12. That's the return and identifier of a particular aircraft, and it's when a radar inquiry was made. So the air traffic controller can look on a map like this, doesn't look like this, but he can tell where that particular airplane is, who it is, the type it is, what altitude it's at, and generally what direction it's moving in. So it makes them able to know who they're talking to, where they want, where you are, and where they want you to be. So it just facilitates moving stuff around. All right, we're going to talk about weight and balance, and it's important, and this is the reason why. If that's your airplane, and the donkey is the engine, and the people and the luggage and the equipment inside are doing that to the airplane, you're going to have a problem. It's going to be really hard to get the airplane to take off the ground like that. So it's important we keep this whole thing in balance. And the way we do that is with weight and balance. Or, as one of our participants talked about, load and moment, which is really complicated stuff. But basically what's happening We've always experienced this. Has anybody ever or never been on a playground with seesaws? Okay, everybody has. So if you got Fat Albert on one end and you've got Skinny Minnie on the other end, which end is going to be down? Fat Albert's end. So Skinny Minnie is going to be up in the air once Fat Albert gets on that lever. So basically the same thing happens with an airplane. With the illustration that's up here, if you put too much weight in the back, the tail of the airplane is going to be down low, just like these jets that are depicted here. If you put too much weight in the front, the opposite happens. So to make sure that everything works properly, we need to make sure that we have our weight of the engine and the instruments and all that at one point, and then everything else at another point, and they have to balance out, just like a balance scale in chemistry when you were in high school or what have you. That's the same concept. Wings generate a certain amount of lift, but they have to be at a certain angle to do that. If the angle is too much, it's not going to make lift. If it's too little, it won't make lift, and you have to have lift to fly. There's a maximum amount of weight that the airplane can do overall. And how stable the airplane is going to be based on where all of this loading is. Before we fly, we compute a weight and balance, and we control it by putting the airplane or things in the aircraft in the right place. So you just can't take your 4 scuba tanks, your golf clubs, and 3 big people in the back of a 182. It can carry a lot of weight overall, but if you don't put it in the right place, or it's too much, or both, then you can have problems. So suffice it to say, the pilots and the scanners and everybody in the aircrew are concerned about the overall weight and where that weight is put in the airplane. And there are charts to do that. There's also electronic ways to do it that we use in our electronic bags, like Foreflight and so forth. So we always want to make sure that whatever weight we have is within limits, and it's put within the spatial limits that are acceptable by the airplane. That's commonly known as your weight envelope, your weight and balance envelope. If it's outside of that, you may not be able to get the airplane to be stable enough to take off. It may be too angled to take off and sustain flight. So it's a bad thing. So it's important that everybody does their part. For our part as crew members, we need to be honest with ourselves and the other crew members in revealing that, though if you look at my body, you would go, oh yeah, he's only 170 pounds. Well, that's true. However, I've got 75 pounds of luggage with me that I go on the mission. And so the guy next to me is the same thing, but he's 210. So we have to think about that. You have to be honest with how much you and your gear is so the pilot can correctly calculate the weight and balance for the airplane. That's the shortest way to do it. One of the jobs of the observer is to assist in doing that, placing the luggage and the equipment and the people in the right places. This basically covers all the stuff that can happen. Forward center of gravity makes it hard to get elevator authority to raise the nose, to rotate the airplane and get it to take off. If it's too far to the rear, then you might not be able to lower the nose. So those are bad things. Down at the bottom of this list, you'll see the term AOBD. The AOBD is the Air Operations Branch Director, who is in charge of all air operations, and they're called the AOBD. So they're responsible to double check that, and before a mission is launched, the AOBD will talk with the pilot in command, possibly the observer, and make sure that all the things are in parameters, and they will sign off on that before the mission can be launched. Okay, so that'll keep this from happening. You ever see that? Don't get in the airplane. Pre-flight inspection. Basically, I touched on it earlier. You want to make sure there's nothing hanging off the airplane and that it's mission ready. So basic knowledge of the items on the pre-flight checklist is important, and we're going to talk about those. Earlier, when we talked about the parts of the airplane, it was important for you to know those up front so that when we get to this portion, you know what we're talking about. We're checking for safety. We're going to make sure that the airplane is airworthy. So whose job is it to do that?
Ultimately, it's the pilot in command.
Okay. In addition to the pilot in command, who can do the pre-flight, do you think? Who can participate in facilitating that?
As a pilot in command, you can delegate that particular task, but you're still ultimately responsible.
Absolutely. Okay. So we do a number of pre-flights. We do a pre-flight on the airplane prior to it moving. We do a post-flight on the airplane after it's put to bed. But we also do a kind of pre-flight before we move the airplane, and that's when you're getting into the aircraft handling and movement training, which is a little bit different, but it's also a pre-placement inspection to make sure that you're not going to run into anything and damage the aircraft. So basically, we're looking to make sure that there's enough oil in the airplane, all the control surfaces work, they work correctly, so that when you turn the yoke to the left, that you get the right response with the ailerons. When you step on the right rudder pedal, that the rudder moves in the correct direction. There have been cases where people will try a control surface and they'll find out that when you turn the yoke to the left, that instead of the ailerons moving in the correct direction, they move in the opposite direction. The airplane just came out of maintenance and it was inadvertently rigged incorrectly, which can be very, very bad. You don't see that unless you actually move those parts. So we use a checklist to walk around, and in the next slide, you'll see what checklist looks like to pre-flight our typical Cessna aircraft. If you're asked to help, you can read out the items without touching them and have the pilot do the actual touching and inspection. Or if the pilot's comfortable with you or you're another pilot, you can do that under the delegation of the pilot in command. When the walk-around's complete, you're checking for constructional components like antennas. Are there oil leaks on the ground? Are there oil leaks or fluid leaks around the airplane or on parts of the airplane, like the brakes, in the engine cowling, that kind of thing? So there's a comprehensive list that you need to check each one of those. And it's very important to make sure that while you're doing this, you're following the checklist in the order of the checklist. Okay, over on the right-hand side, you can see a checklist, and we have to use the manufacturer's checklist. And these are some of the items that you're talking about. You're looking at control. We touched on all of these already. One of the things that often gets missed is tire pressure. There are specific tire pressures that are important, and CAP particularly now is emphasizing that the tires need to be inspected. 1 or 2 PSI short or over can have a severe impact on the handling of the aircraft on the ground. So it's important to make sure that you stay on top of that. A good idea is to make sure there's a pressure gauge somewhere in the aircraft so that check can be done consistently before and after you fly. I've gotten into the habit of walking around and carrying the checklist, even though I know what's there. You can forget stuff, and that's what checklists check against. So I would advocate doing it just as the checklist says. Whether it makes sense to you or not, it's there for a reason. So please go ahead and do that. Okay, ground operations. We're getting close to the end here. There's several simple rules. One is safety first. We always use procedures and checklists, and though we may have to deviate from some common ones, Use common sense and prudent judgment. If you get distracted in the middle of pre-flight inspection, if you're not sure where you left off, go back and begin again, because you could miss something very important just because you had a brain fart and you were distracted and you went, I'm not sure. If you go, I'm not sure, it's time to go back and get sure. I would advocate doing that. Some of the safety things around airplanes that we need to do: no smoking. Colonel Denisick mentioned that earlier. You want to stay clear of moving parts of the airplane. And that's not just the propeller, but flaps, ailerons, elevator can move up and down. If you're short and you're walking under the wing of a 172, as I have at almost 6 feet, which is not particularly tall, but walking around and not paying attention, I'm looking down at the ground. I've gotten more scars on my forehead from running into flaps that were extended or ailerons that were in the down position than I'd like to think. And so just be aware. I would probably be mentally in better shape if I paid more attention with that. Certainly had less head trauma. Look around for that. Stay clear of things and just have your head on a swivel. Staying on the keep clear thing, it's very important to consider the propeller a lethal instrument of death. Do not get in the arc of the propeller, even if the engine is cold, but particularly if it's been run in the last hour or so. For various reasons, you could have an engine crank off independently, and it doesn't happen often, but it's not a pretty sight if it happens. Just stay clear of the propeller arc, particularly when you're pre-flighting and you're preparing to pull the aircraft out of the hangar or push it back in, and you're talking about using the tow bar. Get to the side. Colonel Denisick is absolutely fanatical about that, and I have to give it to him. It's made me aware, so keep that in mind. Moving and loading the airplane, we do a pre-move walk around for the entire environment as well as the aircraft. For emergency situations, we're talking entry and egress, and we're talking about safety around aircraft. Safety around aircraft also touches on some of the things that as aircrew we need to look at. And I would submit to you that it would be beneficial to plan on doing the overwater training, because it's a requirement for aircrews. If you're going to be far at any point, you're going to be farther than gliding distance to land if you're going to be over water that much. So that's required training. So you might want to start thinking about that now. Part of that is also your entry and egress from the aircraft. In emergencies on the ground, there are procedures. In the air, on the ground, there are procedures. In the water, there are procedures. And they're similar in a lot of ways, but there are unique things. Anytime you're in the airplane, seat belts and harnesses, should wear them all the time. It would not be uncommon in flying in mountainous terrain like we sometimes do, that you get turbulence on the downside of the wind flow, and so you could get bounced around. So if you're not belted in securely, you can bounce your noggin, you can get thrown around. So belts and harnesses should be comfortably snug, and if it gets more severe, make sure you tighten them down even more. Fuel management, we talked about earlier. The pilot should brief the crew on how much fuel is needed and where we're going to refuel if necessary. As a scanner, a good reminder, since you may be the one, a scanner or observer, you may be the one who's calling in the ops normal call. So that's a good time to double check with the pilot and assist with fuel management. Running out of gas is not a good thing. So have some conversation about that. Okay, while taxiing safety, while we're taxiing, everybody in the crew is additional sets of eyes to the pilot. We want to prevent collisions with the aircraft and ground objects and vehicles. Helping the pilot find and stay on the taxiway, particularly in bad weather, low visibility, or night, is important, but our common common activity is during the daytime when you have ambient light. Many of the airports that we operate from, and even simple ones, relatively simple ones, like HANA, the procedure now that's standard is pulling out a taxi diagram, and they're available a number of different places in different ways. But before the airplane moves, it's important that and useful for a scanner or observer, in addition to the pilot, before you crank up, have a briefing about what we're going to do for normal things, for taxiing, where we are, where we're supposed to go, because air traffic control is going to tell us, give us taxi instructions and so forth. And we got to figure out where we are, where we're supposed to be, and how we're going to get there. So having a diagram and looking at that before you start up the engine and start rolling is a good idea. As the non-pilot, you can help the pilot by looking at that diagram, because he or she is looking outside. Look at that diagram and say, okay, this is where we are. To get where we want to be, we got to go at this taxiway. We need to make a left turn and so forth. And it helps the pilot and verifies that what they're thinking is correct as well. Anytime we're taxiing, if there's an obstacle within 6 feet, we need to get out and push, which means shutting down the engine. So before you start up, it might be a good idea to walk around and make sure the entire area is clear and that you have that. If you're within 6 to 10 feet, get a marshaller, and we're going to talk about that in a minute, or a wing walker, and keep a sterile cockpit. We're not talking about how good the luau was last night. We're just paying attention to business. Hand signals we're going to talk about in a minute, but use common sense. Sometimes line people or marshallers are new or inexperienced, and they may not be using the same thing. If you're not sure as an aircrew member what they're telling you, let them know and just give them like, I don't know, kind of sign. And then we're going to touch on airport diagrams and markings here in a minute. Okay, so a marshaller should be to the left of the aircraft and in view of the pilot. So as illustrated here, and they usually have a high visibility vest of some sort or covering on of some sort, and use batons or ping pong paddles or something as signaling devices. And that's pretty normal. In the next slide, we're going to see some of the ones. They're pretty well self-described. I would suggest that one of your techniques or things to look at training for additional training is there is a training segment on flight line marshalling. And these signs are universal to that. So get familiar with these because you're going to see them at the cockpit. And you've probably seen them on YouTube things and so forth, but they're pretty self-explanatory. If you want them to come forward and turn left, you're signaling move with your left hand and you're pointing with your right hand the direction you want them to go. If you want the opposite, you just switch the hands. This is pretty obvious.
Yeah, you might even see some of these on the test.
That's true. You might see all of them on the test. This is something you can do for those who are cadets and those who work with cadets and senior members who might not do anything but flying stuff. This is something that can be done as an activity during a squadron thing. It could be part of a safety requirement for your monthly safety. It's easy to do, it's memorable, and also it's the qualification that cadets and seniors can earn and go on their squidders so that they can actually work the flight line when we have missions. Let's see next. Hands crossed over the head is stop. It's pretty obvious. And a lot of these we use just in common day things. Now this is not common, what we're looking at, airport signs and markers. There are a number of YouTube things that you can look at that describe these, but in short, the top one is taxiways. Just follow the yellow line, follow the yellow brick road. These are what you're going to confront on an airplane when you're coming out of a parking area and you're trying to get to the active runway. Before you get in the runway environment, If you're on the side that has the solid lines, you can't cross those. If you're on the side with the dashed lines, you can cross those. So you'll get familiar with these, and they're published in a number of FAA documents if you want more information. So how do we know where we are on the airport? They have these signs. So if it's a red background with white characters on it, it's telling you the one on the left is runway 15 is to your left, and 33, the opposite end, is to your right. 15 approach is runway 15's approach corridor. Is that the right terminology, Colonel?
Yeah, sometimes if you have a taxiway going right across the end of a runway, there'll be a sign like that to warn you that even though you won't be on the runway, you'll be affecting the approach to that runway.
You're approaching it.
ATC
Right.
clearance across that.
So it's a runway 15 is coming up, be aware. ILS is the instrument landing system. It's an area that you don't want to be in when it's operational. So it's there, you'll see that. And then obviously the international, don't go in here. You don't want to be in that particular area. Down on the bottom was a further depiction of what I spoke about just a few minutes ago. And these are visible from the runway, and they help you determine when you are clear of the runway. So the one at the bottom and on the left-hand side.
If you're going vertically up, then you could cross that one without permission. But anytime you see a solid line facing you, you got to get permission to cross it.
Black background, yellow letters tells you where you are. So in this case, you're on Alpha, probably a taxiway. Okay. And 22, that would mean there's an Alpha 21 and 23 or something like that. So it's got a lot of outlets on the taxiway. Directional signs will tell you which way to taxiway Bravo, Charlie. You're on Alpha. Alpha is also off to the upper right, and Charlie is direct hard to your right. So that gives you direction. Okay, wake turbulence. Basically, big airplanes moving through the air make a wake, just like a boat going through the water. And the heavier they are, the bigger wake they make. These things, and they make a vortex, kind of like a little tornado. They can be very, very fast, and they can upset an airplane of our size and bigger without much problem. So we want to make sure that when we're landing, we're not landing into an area that has, or taking off into an area that has wake turbulence. These wakes can settle about 500 to 800 feet below the flight path. So if you were going to take off and you were coming up behind a large aircraft that has just taken off, it may be up in the air and you're thinking you're clear and you're going to be out of the wake, and the wake is settling down. It's above you, but it works its way down and you get it. So the airports with control towers are going to make statements like, clear to take off, runway 2, caution wake turbulence. And that lets the pilot know that something big just took off or just landed, and that you need to be aware of that. Next slide is going to show what these wakes can look like. And I think they're pretty dramatic. And you can see that they changed from the middle one. That's it for the wake turbulence.
I'll just add that one of the most severe wake turbulence actually comes from hover taxiing helicopters. And so we have certain criteria as far as spacing behind other aircraft. But if there's a helicopter out there on a taxiway or anywhere near you, you need to be at least 500 feet away from that thing, because it's a tremendous amount of wake turbulence off those rotors.